Hello, welcome to another in our series of CMMI Tech Talks looking at specific practice areas within the CMMI model. Today, we are going to have a look at the verification and validation, otherwise known as VV, practice area. We shall discuss the intent of this practice area and look at what value it can provide to an organization, as well as looking at the individual practices to see how they can be used to improve the quality of an organization's solutions, products, or services. Quality is one of the classic constraints that needs to be considered when managing a project, as well as the big three of cost, schedule, and performance. The ability to deliver a project at an acceptable level of quality is essential to the project's success and the long-term future of the business. VV is one of four practice areas within the ensuring quality capability area, which is in the doing category. The ensuring quality capability area contains PAs that look at the subject of quality from many different viewpoints. The verification and validation practice area focuses on ensuring that solutions have been developed to meet their agreed requirements, verification, and will perform as intended in their target environment, validation. It is important to understand the distinction between these two related but different concepts. Both verification and validation are closely coupled to the requirements of a solution, product, or service, but they are looking at them from two different perspectives. Requirements are the way we capture and agree what a product or solution must do. They define the customer's needs and wants. Validation is the process of confirming that the agreed solution meets the customer's needs and will behave as intended in its target environment. We sometimes use the phrase, "build the right thing," as a shorthand summary of the process of validation. By contrast, verification is concerned with "build the thing right." In other words, does our solution truly meet its specification and fulfill the agreed requirements allocated to it? Let's start our tour by looking at the key mandatory model components, the high-level intent and value statements. Intent confirms selected solutions and components meet their requirements and demonstrates selected solutions and components fulfill their intended use in their target environment. Value increases the likelihood that the solution will satisfy the customer. The intent statement has two constituent parts which echo the distinction between verification and validation that we've just discussed. Notice, however, the value statement applies equally to both verification and validation. Both activities will help us to deliver a solution to our customers that will satisfy their needs. The practices of verification and validation go up to practice group level 3 and reflect the expected evolutionary progression towards increasing capability. The level 1 practices simply direct us to perform basic verification and validation activities. At level 2, we encounter practices that require more planning and management of V&V activities by selecting components to be examined, choosing the processes and methods that will be employed, and defining the V&V environments. At level 3, we extend our V&V activities by introducing organizational standardized criteria to focus the V&V effort on critical areas and to review the results of these activities to feed back and improve our V&V practices. Let us turn now to the individual practices within the VV practice area. There are two level 1 practices. VV 1.1 looks for us to perform some basic verification activities to ensure that our requirements have been correctly implemented. And VV 1.2 directs us to perform validation of our requirements to ensure that the final solution will function as intended in its target environment. Both practices include a statement directing us to record and communicate the results of the associated activities however they are performed. In effect, these Level 1 practices simply echo the definitions of verification and validation and look for us to start performing appropriate activities. At Level 1, the practices make distinct reference to either verification or validation. There is some overlap in the type of activities the practices are asking us to perform, but the activities need to cover the two different points of view. Starting at Level 2, this changes. All Level 2 and 3 practices specifically refer to both verification and validation. Hence, although the disciplines of verification and validation have different focuses, the Level 2 and 3 practices apply equally to both. For example, VV 2.1 states, select components and methods for verification and validation. The practice is about choosing when and where to conduct verification and validation activities and what methods to use. All projects and organizations are resource constrained and need to focus their efforts on areas where they will get the most benefit, and this is certainly true for verification and validation. We may not need to carry out the same level of verification on an existing off-the-shelf component as we would for a newly developed custom one, so we might reduce the level of verification we perform here. However, we might want to increase the validation we apply to these off-the-shelf components to ensure they do fully meet the customer's needs, work together properly, and ensure we're not making inappropriate compromises because of using off-the-shelf components. The methods we select to perform verification activities may be very different to those we use to perform validation, and there may be common tools or methodologies for doing both, but the intent of this practice remains the same for both. VV 2.2 is concerned with ensuring that we have the necessary environments available to us to perform the activities we identified because of practice VV 2.1. Typically, we need a range of different environments that will enable us to perform the required verification and validation activities effectively and efficiently. For a software development project, for example, we may be able to perform simple unit testing in the software development environment, but once we start integrating modules together, we may need a separate dedicated test environment, which is more representative of the final target environment to enable the testing of interfaces. If we are looking to stand up a new support service that can handle a specific volume of service requests, we would want to test this on a separate but representative environment rather than risk compromising existing service levels by testing it on our live service system. All these environments need to be defined and planned for to ensure they are available for use when required. Otherwise, verification and validation activities may be held up or not adequately cover all the critical elements or components. For example, a new emergency responder communication system might include specific human factor requirements, stipulating the usability of the physical components and confined vehicles by personnel in cumbersome protective equipment. While we might be able to partially verify these requirements and validate our proposed solution using simulations or lab-based prototypes, it may be that only by installing the prototype kit in an actual vehicle with suitably equipped operators that we will be able to validate the feasibility of our solution and the practicality of the specified requirements. However, the availability of both an actual vehicle and a real operator may be severely restricted due to operational schedules, cost, or other reasons. So to secure this particular environment may take a lot of planning and become a major dependency. VV 2.3 tells us to define procedures for verification and validation. In any form of test activity, replication of issues and predictability of results is extremely important. A test, which will have different outcomes depending on when it is run or who runs it, has very little value. If we identify a problem, we need to be able to replicate it to understand the problem and take the necessary steps to fix it. By defining procedures for verification and validation activities, we can remove variation in the approach and help to ensure consistent, repeatable results. Procedures would typically include not just the test process itself, but also the setup and configuration of the environment on which the test was performed, any test data used to establish the entry conditions, and any other information which may influence the result. At level 3, we encounter practices which help us refine our verification and validation activities and start to look at them from an organizational perspective. We've already mentioned that organizations are usually resource constrained and may not be able to carry out exhaustive verification and validation activities. However, we need to perform sufficient verification and validation activities to satisfy ourselves and our customers that the risks of problems are low. Therefore, we have to identify strategies that will help us focus our efforts where they will have the most benefit. VV 3.1 introduces the idea of standardized criteria that we can use to determine verification and validation activities and levels of effort. Criteria might state, for example, minimum levels of test coverage or acceptable levels of escape defects. These criteria may be influenced by customer or project-specific requirements or risks, but they can also be driven by organizational constraints. For example, if the organization in question has certain regulatory or compliance requirements that they need to adhere to, this may have an impact on the nature of the verification and validation activities that must be performed to ensure these requirements are met. Finally, VV 3.2 asks us to analyze and communicate the results of verification and validation activities. This is a level 3 practice and therefore goes beyond merely looking at and reacting to individual verification and validation results. This practice is looking for a more holistic analysis of the results of verification and validation activities across the organization as well as on individual instances and data. The verification and validation activities performed should have been driven by the organizational criteria we discussed in the previous practice. So here, we look at the results and analyze them to see if there are any wider lessons to be learned. Are the organizational verification and validation criteria working well for us, or are they too restrictive or permissive? Are our selected verification and validation methods as effective as they should be, or can we improve them or consider alternatives? This practice drives the ongoing improvement of verification and validation activities conducted throughout the organization. These then are the practices of the verification and validation practice area. To summarize the main points, the VV practice area covers performing verification addresses whether the work product and solution properly reflect the specified requirements, such as you are building it right. Performing validation demonstrates that the solution will fulfill its intended use in its target environment, such as you are building the right thing. Selecting what components to apply verification and validation activities to, and choosing appropriate methods. Defining and securing the necessary verification and validation environment. Establishing organizational verification and validation procedures and criteria. And analyzing verification and validation data to identify improvements. Thank you for joining us for this CMMI Tech Talk. If you have questions, please contact us at support.isaca.org.